Let's understand this in respect to the diagram which we drew for clock jitter. So here was a diagram which we drew at that point of time. This was my flip-flop 1, this was my flip-flop 2, this was my combinational block, and we've said that this was time equal to 0 and this was time equal to t, and the clock source had to give its clock at time equal to 0 and time equal to t. But that was, we were assuming idle clocks. In practical scenario, what happens is this clock source needs to drive, or the clock needs to go to a lot of blocks. We know that there are millions of transistors on an IC, right? So there are a lot of blocks where this clock needs to go. And hence we know that the concept of repeaters or buffers are added in the path to restore the signal strength or restore the value of the signal, and also that if we break the wire or the interconnect by adding repeaters, suppose this was my interconnect of 100 meters, then my delay would be 100 square. If I break it into two parts by adding a repeater in between and say that first interconnect is 50 and the other interconnect is also 50 meters, then it will be 50 square plus 50 square, which would surely be less than 100 square. This is just for your reference, guys. What I'm trying to bring to your notice is the clock does not get directly connected to all the blocks. It needs to be passed through a buffer chain or driver trees, etc, etc. In this case, my clock 1 will come after the clock is ready plus t1 plus t2 time. Let's say t1 is the time taken by this buffer, t2 is the time taken by this buffer. Whereas my clock 2 will come after the clock is ready, t1, it comes in its part, t3 and t4. So this is for clock 2. So this difference in time between these two is nothing but clock skew. Now we saw that clock skew varies the phase of my clock, but it does not alter my frequency or the period, which we just saw. And this variation of the phase happens due to primarily two reasons. One is the interconnects. We saw that it's proportional to L square. So one is the interconnect length, and the other one is because of the buffers, which will also add to the delay on the path. Though we saw that it will reduce the length of the interconnect, but buffer itself will have its own delays. So these are the two reasons why the variation in phase happens, but there is no change in the frequency. The other point which we need to understand is that clock skew can be positive or negative. Now it's very common. If my clock source is taken in this direction, then we know that T2 minus T1 would be positive. If my clock source would have been in this direction, then T2 would have received its clock first, or the block 1 or clock 1 would have been received late, and still if we consider the skew as T2 minus T1, then the sign would change. So clock skew would be positive or negative depending on the position of your clock source, if it's here or here, depending on the positions of your blocks as well, and which way you are routing your signal. Again, it's very common sense. If you are getting confused, this is my block and this is my clock source, and if I want to take the difference between T2 minus T1, it will be a positive value. If my clock source is here, this will come first and this will come second, but because I want to take a difference of second and first this way only, this would be a negative value. It just shows how are you going to route your wires or how are you going to place your clock source. In simple words, what you need to remember is clock skew can be positive or negative. Clock skew varies the phase but does not change the frequency or the period of my signal. And very important is clock skew is constant from cycle to cycle. Remember, in clock jitter, it was temporary variation of the clock period. Sometimes the clock period could be less than t, sometimes the clock period could be greater than t, so on and so forth, and it keeps on varying for each cycle. Whereas clock skew, because it does not alter the frequency or period, it is constant from cycle to cycle. In simple words, it says that if clock 2 has lagged clock 1 by delta in the first clock cycle, and then on next all the cycles it will lag by the same amount. This can be easily seen from this waveform also. There is no alteration in the lag which was in the first cycle or in the second cycle for nth cycle, which says that clock skew is constant from cycle to cycle. This is not true for clock jitter. It varies from cycle to cycle. Clock skew, there is no change in frequency or period, which is again not true for clock jitter because it varies the period of my signal. In simple words, clock skew is nothing but a difference in the clock received between two receiving points on your chip, and we say that the variation in the phase happens but there is no variation in frequency or period. Now sources of clock skew, one or two I have just mentioned here. One is the interconnect variation. We already saw that, the length of the wire. We also saw buffers present. Other one could be environmental variations like temperature and power supply, and so on and so forth. So clock skew also is a very serious problem, which we will see how to minimize in the future clips. Hope you have followed. Stay tuned and thank you very much.